Hi Trigoner, so these are notes 3.4 day 2. We're still talking about quadratic functions, and our objectives for today are going to be able to write an equation of a quadratic from given information with and without a calculator. So I might give you the vertex, I might give you some x-intercepts, I might give you a graph. The second objective is to be able to understand when to use vertex form or factored form when writing an equation of a quadratic. So depending on the given information, one form might be easier than the other. The third objective is to be able to complete the square to transform a quadratic from general form to vertex form. So again, we're talking about quadratic functions, and general form would be y equals ax squared plus bx plus c. And what we're going to do for the first part is we are going to go ahead and look at each graph and see if we can write an equation. So for this first part, you are thinking about transformations on the parent function y equals x squared. So go ahead and pause the video and take a look at that first one and think about what transformations are performed on the parent function, again, y equals x squared. You might want to think about, is there any vertical stretch or shrink? So notice, like, for example, what would the a be? So if we go right one and up one, notice there is a point there at 0, 3. So thinking of our parent function, we went right one and up one. So again, I'm expecting my a to be 1. Also notice that you can find the vertex. It's at -1, 2. So I believe the easiest equation for you to start with would probably be to think about vertex form. So go ahead and pause the video again and see if you can write an equation for the graph of A in vertex form. Okay, so again the A was 1, so y equals the quantity x plus 1 squared plus 2. Let's go ahead and try part B. Now again, thinking about, notice I went right 1 and down 1. So think about what the A would be for part B. Go ahead and pause the video and write an equation thinking about transformations on the parent function y equals x squared. So we went right 1, down 1. So again, I'm expecting the A to be -1, and the vertex was at -1, 2. Okay, go ahead and try part C. Again, this time notice that I went right 1 and down 1/2. Go ahead and pause the video and try part C. Notice the A must be 1/2, and it must be negative because, again, the parabola is pointing down. So it opens down. So notice that we have a vertex at 0, 1. And again, I believe for me, it was easiest to think about this in vertex form. Okay, so again, you probably wrote y equals -1/2 x squared plus 1. Okay, let's go ahead and try the last one. Again, notice for this one, I went right 1 and up 2. Go ahead and think about what the A would be and think about transformations on the parent function. Okay, so for part D, notice that we had a vertex at -1, 0, and again, the A must be 2 because we went right 1 up 2, so there must have been a vertical stretch by a factor of 2. So let's go ahead and think now about a quadratic. Okay, so again, notice sometimes a quadratic has a maximum if it opens downward. Sometimes the quadratic has a minimum if it opens upward. Notice that we have our vertex h, k. We have our axes of symmetry. Notice we have our domain, all real numbers. And again, you could think about the range depending on if there's a maximum or a minimum point. This is important for us to remember. If you wanted to find the x coordinate of the vertex, it is opposite of b over 2a. So what we're going to do now is we're going to think about completing the square. So we're going to start by factoring a perfect trinomial square. So for example, if I have x squared plus 2x plus 1, it's called a trinomial square because you can factor it as a binomial squared. So the quantity x plus 1 squared. Go ahead and pause the video and factor part B. So first we factor out a common term of 2, and then you have x squared minus 4x plus 4, which again is a trinomial square because you can factor it as the quantity x minus 2 squared. Also, I want you to notice that if you take half of the middle term and square it, you get 4. Over here, half the middle term and square it, you get 1. Okay, so what we're going to do now is we're going to use that, the fact that we have half of the middle term squared to get 1, and that's how we have our trinomial, it forms a trinomial square, to help us complete the square for part 3. So again, what we're trying to do is we're trying to write an equation in vertex form. So we have general form. So the first thing we're going to do for part A is we are going to add 1 because we want to isolate the x terms on one side of the equation. So next we're going to have to try and find the number that will form a perfect trinomial square. So that would be 12 divided by 2, which is 6. 6 squared is 36. Now here's the problem. If you add 36 to the right side of the equation, you have to add 36 to the left side of the equation to keep the equation balanced. So I have y plus 37 equals x plus 6 quantity squared. So notice I factored the right side of the equation because, again, if I have a 12x and a 36 and an x squared, that's a perfect trinomial square. So now we are done. We have x plus the quantity x plus 6 squared minus 37. So let's think about what makes this particular equation easier if we wanted to analyze the equation for axis of symmetry or vertex or things like that. So notice if it's in vertex form, we know that the vertex is -6 comma -37. Okay, let's go ahead and try the next one. Now for the next one, and I should have said over here that the last step was to factor. Okay, so over here notice that after we add 3, you're going to have to factor out the x squared. So that's actually, we're going to make that step 2. And we're going to say factor. So we're going to have to factor out the negative. So now when we look for our number that will make this a trinomial square, we have -4 divided by 2 squared. So if we add 4 to the right side, you have to add 4 to the left side of the equation. However, be careful because you really added minus times 4 because you have factored out a negative sign. So we're going to have to add a -4 to the left side of the equation. So we have y minus 1 equals the opposite of the quantity x minus 2 squared. So again, now we have a perfect trinomial square. So now we know that we have opposite of the quantity x minus 2 squared plus 1. We're in vertex form. So again, our steps are isolate the x terms, factor, find the number that will form a perfect trinomial square, which is the middle term divided by 2 squared, and then lastly, factor. So let's go ahead and pause the video and try part C on your own. You did. Did you add 1 to isolate the x terms? Then did you factor out the -3? Make sure that you have a negative sign here because negative times negative is positive. Now, when you found the magic number that would make this a perfect trinomial square, you took the middle term squared. Notice you added 4, but you have a -3 here. So you're really adding a -12 to the right side of the equation. So make sure that you add a -12 to the left side of the equation. So now we have vertex form. And again, this is great because if I wanted the vertex, I would know that it's 2, 11. Okay, so let's go ahead and take a look at this last one. Now, notice if you add the 1 and you factor out the -2, for this one, your middle term would be half of -3 squared. And again, that's not terrible, that's 9/4, but sometimes if I get a problem like this and it has an ugly decimal or a yucky fraction, I don't think I would use completing the square. I think I would try something else. I think what I would do instead is find the x-coordinate of the vertex, which is opposite of b over 2a. And now to find the y-coordinate of the vertex, you would substitute 3/2 into the equation for x. So go ahead and pause the video and see if you can write part D in vertex form. Okay, so again, I have 3/2 is my x-coordinate of my vertex. If you substitute 3/2 into the equation for x, you could find y is 7/2. So we know that we have y equals, and again, here is our a, -2 times x minus 3/2 quantity squared plus 7/2. So again, you could have completed the square if you wanted to, but if you have ugly fractions, sometimes it's a little bit easier to find the x with opposite of b over 2a and then substitute that number to get your y value. Okay, so for part 4, we're going to write an equation of a quadratic, and notice that I have very minimal information. So for this one, it might help if you get a visual. We have a vertex of 2, -1 and a y-intercept of 4. So that means that it must open upward. So why don't you go ahead and pause the video. My suggestion would be for our skeleton equation here, I would start with vertex form. Whenever I'm given the vertex, I usually start with vertex form. So go ahead and give that a try. See if you can use 0, 4 to find your A. I substituted 2 in for H and -1 in for K. So now I'm going to temporarily put 4 into, I substitute 4 for Y and 0 for X so that I can find A. So I add 1, divide by 4, my A is 5/4. So why don't we go ahead and try part B now. They didn't give us the y-intercept, they gave us some other arbitrary point. The only thing special about this point is that it is a solution to the quadratic. So -1, 4, and then 3, -4. So that means that my parabola, my quadratic, must open downward. So go ahead and use, I would start off with vertex form since we were given the vertex. Pause the video and give it a try. So I put -1, I substitute -1 for the H and 4 for the K. I need to use this point over here. Temporarily I'll substitute -4 in for Y and 3 in for X so that I could hopefully find A. So let's see, I have 16A plus 4. So if I subtract 4 and divide by 16, my A is -1/2. So I have Y equals -1/2 times the quantity x plus 1 squared plus 4. And this is consistent with my graph because we knew that the parabola opened downward, so the -1/2 was expected. Let's take a look at number 5. So for number 5, I think it would help if you sketch a graph. Notice the x-intercepts are at -5 and 1. And notice they just gave us another point, 3, 8. So again, I don't know, there's nothing necessarily special about the 3 and the 8 other than it is a solution to our quadratic. So it looks something like this. The problem is we don't know what the vertex is. However, we do know what the x-coordinate of the vertex is. Wouldn't it have to be halfway between the -5 and the 1? That's good to know. But again, since we don't know the vertex, I think I would start in a different way. I'm going to write this as A times x minus a -5, and then the quantity x minus 1. So notice if -5 and 1 are truly x-intercepts, you could write the equation like this because, for example, if I substitute a 0 in for y, notice then we would say, oh, well, x equals 5 and x equals 1 are x-intercepts. So what we need to do now is we need to find the A. So pause the video and think about what you could do to find the A. Notice we haven't used the point 3, 8 yet, so we know that 8 is A times times -2 times 2, so we end up with A is 8 divided by -4. So again, some people like to call this factored form. Okay, so if we take a look at number 6 now, notice they gave us x-intercepts and this time a maximum. So go ahead and pause the video and sketch a graph and see if you can write an equation. Okay, so for number 6, notice that if the x-intercepts are at 3 and 9, and again our axes of symmetry then would have to go right through the vertex of our quadratic. So we know that halfway between, this is a symmetric figure, would be 6. So if our maximum is 8, we know that the vertex must be at 6, 8. So since I know the vertex, I would start with vertex form. So now we have not yet used the 3 and the 0. I guess we technically have, but I could temporarily use 0 for y and 3 for x to find the A. So we know that A is negative 8/9. Let's go ahead and think about number 7. It's a little different. Go ahead and pause the video and give it a try. Okay, so hopefully realize that if we have points at negative 2, 5, and 6, 5, notice that those points are on a horizontal line. So that means that the vertex would have to be halfway between negative 2 and 6. So the vertex would have to be at 2. I should say the x-coordinate of the vertex, or the axis of symmetry. So notice that the axis of symmetry would have to be at x equals 2. So you know that the minimum is negative 3, so we have the vertex. So again, since I have the vertex, I would start with vertex form. So now we could use either point. How about this one? Substitute 5 in for y temporarily, negative 2 in for x to find the a. So you get a equals 1/2. So for the next problem, number 8, I would like to show you how to use your graphing calculator. So go ahead and get your graphing calculator, and we are going to enter these 3 points into your list. So go ahead and go to stat, which is in, if you count this first row, is in the third row, third column. Now edit, because we're going to enter information. So I have some information in there already. So I'm going to go to the tippy top and hit clear enter. And I clear all that out. I'm going to go to the tippy top and hit clear enter and clear all that out. So I'm going to enter my x coordinates in list 1 and my y coordinates in list 2. So my x coordinates were negative 1, 2, and 1. Now, be careful that your y-coordinate is next to its corresponding x-coordinate. So we had a point at negative 1, 7, so make sure that you type the 7 into the first spot. And then we had 2, 1, so put a 1 in the second, in list 2 in the second entry, as the second entry, and then negative 1 would be the third entry in list 2. Okay, so now we're going to go back to stat, which is the third row, third column. This time we want to make a calculation. So if you go down, this is going to be a quadratic. So if you choose 5, the calculator will make a regression equation, which means looks at your data and will try and make an equation of a quadratic that best fits your data. So I wanted list 1 as my x's, list 2 as my y's. Now you could store this. I think that's a great idea. If you go to vars, which is in the 1, 2, 3, 4th row, 4th column, notice you could go right to y vars and then hit enter for function. If you hit enter on y1 and now calculate by hitting enter, notice that when you go to y equals, it pasted the equation into the y1 for you. So again, if you wanted to, I just cleared out. I had something crazy in y2. So if I do a zoom 6, notice it's pasted in there, so I could just look at the equation. Yay, okay. So again, here was my equation. Okay, that had all the decimals in there. So I'm going to go ahead and go back to the home screen, hit second enter. There we go. So the equation was y equals 2x squared minus 4x plus 1. Okay, so for our last 2 examples, we are going to convert to general form. So for the first one, notice that you need to expand quantity x plus 1 squared. So y equals negative x squared minus 2x minus 1 minus 3. And we can change that to general form. And then for the next one, go ahead and pause the video. Multiply the quantity x plus 2 times the quantity x minus 1 and then distribute your 3. But y equals 3 times the quantity x squared plus x minus 2, distribute the 3, and you have converted to general form. Great job, everybody.